Welcome back. Let's do another example, this time where we have constant acceleration. This question is a little bit more complex, but let's give it a go. So the question, a sandbag is dropped from a balloon that is ascending vertically at a constant speed of 6 meters per second. The bag is released with the same upward velocity of 6 meters per second at t is equal to 0 seconds and hits the ground when t is equal to 8 seconds. Find the speed of the bag as it hits the ground and the altitude of the balloon at this instant. So there's a lot going on with this problem, so maybe it'll be a little bit easier if we start by drawing a little quick picture of what's happening. So let's say we have our balloon. Let's draw our balloon. And it is traveling upwards at 6 meters per second. And this is at, we'll call time t is equal to 0. And after some time later, our balloon has moved upwards. And we'll call the position s is equal to 0 from the initial position. And we'll say the position upwards is s of the balloon. And right at the beginning instant, the balloon dropped the sandbag, and that dropped down to the ground, and it took 8 seconds to get to the ground. So let's try and draw our sandbag here. So our sandbag starts with the balloon at t is equal to 0, and then right at that instant, it's dropped and it lands on the ground sometime later when t is equal to 8 seconds. And let's call our position to where that sandbag is on the ground s of the bag. So there's one thing that's missing from here, and that is the acceleration. So if this is, we're assuming this is on Earth, and on Earth acceleration would be downwards, and we'll call this g, and that's equal to 9.81 squared. So we have all of our information. At time t equals 0, the bag and the balloon are together, moving upwards at 6 meters per second. And at that instant, we're going to say that that is when s, our position, is equal to 0. And then at some time, 8 seconds later, we have the balloon has traveled upwards and the sandbag has landed on the ground. And we need to find the position of the balloon, the position of the bag. And we're also going to try and find the speed of the bag as it hits the ground. So we're asked for the speed of the bag as it hits the ground, which is the velocity of the bag, and we're asked for the altitude of the balloon. So the altitude of the balloon is going to be the addition s balloon plus s bag. That's the distance of the balloon from the ground. So how can we begin? Well, if we use our equations of motion for constant acceleration, we can solve for the position of the bag and the position of the balloon after 8 seconds has gone by. So let's start with the bag. So from our equations, we can write the position of the bag is equal to s0, which is just 0, plus the initial velocity of the bag times t plus 1/2 times our constant acceleration term times t squared. Let's make sure that that looks like a t. So if we solve it substitute in the values that we know. We know the initial velocity of the bag is the same as the balloon when it's released, and that's upwards 6 meters per second. So let's assume that the upwards direction is going to be positive. So we know 0 is our S0. Our initial velocity is 6 meters per second. The amount of time that goes by is 8 seconds. Plus 1/2. Our acceleration is 9.81 meters per second squared, and that's acting downwards, so that's negative 9.81. And again, our time is 8 seconds. And if we solve for this, the position of the bag after 8 seconds, when it hits the ground, will have moved 265.9 meters in the negative direction. So we found the position of the bag. Now we can find the position of the balloon. If we use the exact same equation, but the balloon is going at a constant velocity, our acceleration term is just equal to 0. So we have S of our balloon is just equal to S0, which is 0, plus the velocity of our balloon, which is 6 meters per second times 8 seconds. And then our last term is just 0 because the acceleration is 0. So we're left with the S of our balloon is 6 times 8, which is 48 meters. And we can write up. And for the bag, we can write down. So the total position, the total altitude, is equal to S of the balloon, the position of the balloon, minus the position of the bag, which is equal to 48 minus 265.9, which is approximately equal to 314 meters. So when the bag hits the ground, the balloon is 314 meters above the ground. So just remembering that the altitude is the distance from the ground to the balloon, and it's not S of the balloon, or the position of the balloon, because we decided earlier that the position of the balloon at S equals 0 is going to be when the balloon releases the sandbag. So the last question we need to know is find the speed of that sandbag. So we can use our other equation of motion for constant acceleration to find the speed of the bag. Speed of the bag. And we'll call this V of the bag, and that's equal to V0 plus acceleration term times time. So we know V0 was 6 meters per second, and our acceleration is negative 9.81. Our time is 8 seconds. And if we solve this, we get the velocity is equal to negative 72.5 meters per second. And just to keep things simple, we can highlight all of our solutions. So our three answers are the altitude, sorry, our two answers, the altitude is 314 meters of the balloon, and the bag hits the ground at a speed of negative 72.5 meters per second.